Hello, I have with me here a couple of plastic bottles. Now in our last set of videos we talked about modeling the shape of a vase, and in that case a polynomial seemed like a reasonable option. But notice even this 2-liter bottle, trying to use a polynomial to describe a horizontal line and then this curve is going to be tough. And similarly for this palm bottle. So we need another strategy, and that's going to be piecewise functions. And so that's the topic for this section. But before we jump into that, let's review where we've been and just see how piecewise functions will be another tool that will be helpful in certain situations. So let's remind ourselves that empirical modeling is interested in fitting in a model that's based on just data and observations. So we're not necessarily expecting a theoretical underpinning for our model. Now, at first we learned about very basic formulas, linear, exponential, power functions, those sorts of things that are probably not going to be a perfect fit, but they're simple and they're easy to find and use. Our criteria for finding the best one is the sum of the squared error. And in that case, we can use something like a spreadsheet to calculate it. But the problem, of course, is that either there's going to be error or it's not going to be that good of a fit, especially for a bottle like this. So the next option we talked about was a high-order polynomial. And in that case, we are guaranteed to have no error, at least in terms of the data points we're given. But if we are trying to find a trend that will work outside of the data range, it's probably not going to be helpful. And it's possible that even though it might fit the data points, there'll be so much oscillation in between those points that it still won't be a great match for whatever we're trying to fit. So a bit of a compromise is a low-order polynomial. It's more complex than the basic functions, but it's not quite as cumbersome as a high-order polynomial. But it's still going to have error, and it's still going to have potential to not be an appropriate solution. And then there's a problem of what degree do you choose? Because in some situations, a quadratic and a cubic and quartic might be similar for interpolation, but very different for extrapolation, if that's necessary. And none of these examples are going to work for modeling the shape of a palm bottle or 2-liter bottle. So that brings us to our final choice, and that's piecewise functions. And with piecewise functions, we can potentially get a perfect fit still, but probably not have as much oscillation, if any. So the interpolation is probably going to be better, but the downside is extrapolation probably isn't going to make sense. But in the bottle example, we don't need extrapolation anyway. But the biggest downside is that it's going to take more work on our part to find the appropriate function, because generally speaking, a spreadsheet or Maple isn't going to do all the work for us. We're going to have to do some more work on our own. But with the skills we have from algebra class and calculus class, we can do it. And that's what the next couple of videos in this section will be about. So we'll see you there.